Okay, so today we're going to talk about the solution to the interface lab. We were given the new versions of the bank account, checking account, savings account, and the accounts main. So we were asked to design a Java interface called Lockable that has the following methods: set key, lock, unlock, and lock. The set key lock and unlock methods take an integer parameter that represents the key. The set key method establishes the key, lock and unlock the object if the key is correct, and the locked method returns a boolean of true for locked and false for unlocked. A lockable object is an object whose regular methods are protected. If the object is locked, they cannot be invoked. Um, Redesign and implement a version of the bank account classes so that they're lockable. So let's first take a look at our lockable interface. Our lockable interface does exactly what it says: public interface lockable, public void set key, public void public boolean lock, public boolean unlock, and public boolean is locked. And ideally, we could or should at least have some kind of commenting here as to what's happening, and that comes right from the direction. Um, this is a modifier to alter the key, and then we can say that this one locks the object if the key is if the key parameter is correct. This one obviously unlocks the object if the key parameter is correct, and this one accessor turns the locked state of the object. So it's a nice idea to provide some context as to what the intent of these are, since they don't have bodies. Um, and so then we go to bank account, and bank account in this version had already implemented comparable, and now we're having it implement lockable. Um, so we had to add two new variables: private int key and private boolean locked. So in my main constructor here, I just set the default key to 1111. Then I set locked equal to false. And then I took all of the methods down here, and it said if it's not locked, return the name. And otherwise, I returned empty quotes. Um, and again, if it's not locked, return balance. And so all the way through here, we're taking these methods and we are applying the is locked method that we talked about over there. And then down here, we have to actually write those methods. Remember, they have to have a body for this to work. So I'm only letting people set the key if it's not locked. So we take the key, and if it's not locked, then set the instance variable key to the parameter key. We did not put lock checks on these two variables to lock and unlock, because that wouldn't make sense. So if the key is correct, then set locked to true and return true, and otherwise return false. And then same thing down here with unlock, except we set locked to false. And then the is locked function is just returning this dot locked. Now, the one thing is that if a superclass implements the uh, the interface, then the subclass is automatically implemented. Okay, and you'll see then down here, I didn't have to write implements lockable. You can if you want, but you don't have to, because it's inheriting that lockable capability. And then we set up the same pieces here, where we're checking whether or not it's locked, and then the same thing over here in savings account, where we're checking to see that it's locked. And so right now, if I come over here and I run this program, it's going to do it's going to create a bunch of things, and it's going to create a bunch of accounts, and it's going to add to them, and then it's going to do different things and then show me all of the accounts in that list. And these are all of the comparable type. I could make them of the lockable type now if I wanted to. But if I come in here and we'll look at this. We're looking at seeing that S1 is here right now. If I come in here and I do S1 dot lock, and I know that it's 1111. Sorry, that's a capital S. So if I set this up to lock it, watch that there's going to be a change here on the S1 balance 700 rate 2.5 when I run this again. The whole thing just disappears because there's not a toString function. The toString function doesn't work when it's locked. It just returns an empty string. So we can't get that information. And then if I wanted to unlock it, then I could come down here and I could do S1 dot unlock and send in 1111. And now that information will actually appear again. Here's S1. It appears again because I've unlocked it, which means I now have access to the methods. If I unlock it after, let's say I unlock it down here. Oh, that was just comparing them. That was me sorting them. Sorry. If I were, to lock it and then try to add deposit money into it, S1 dot deposit $100, which should make it $700. And then I go S1 dot unlock so that I can see it. So that should make it $800 if I run this. It's still sitting at $700. Whereas if I take that lock off and run it, then it goes to the $800. So you can see that my lock function is preventing these methods from occurring. And so that's kind of the basic idea. Once again, just to reiterate, when you have a class implement an interface, then as you can see back here, that class can be considered by the compiler to be of that interface type. For example, we had that comparable that was being implemented on bank account. Now we have lockable, which is being implemented on bank account. So we can create an array list of lockable objects as well and push these accounts into that. So that is the solution to the interface lab.